So this lesson is on vectors. So how do we describe a vector? The concept is that a vector has both direction and magnitude. Now, we know what direction means. What about the word magnitude? If I use the term magnitude, I mean the length of the vector. So magnitude equals length or size. The direction, the way it's headed, but a vector has no fixed location in space. So what does it mean? Let's think of an example. I use this notation, V with a hat over it, to represent a vector. In print, typically we use boldface for vectors. And one notation that I prefer is this notation. Another notation you'll see on occasion for a vector is written this way. But what does it mean? What does it mean? The first position in the vector representation corresponds to the change in the x direction, and the second one corresponds to the change in the y direction. If we had 3D vectors, of course, the third slot would correspond to the change in the z direction. So typically we think of it that way. If I have a vector u, again, first slot, change in x, second slot, change in y. If it's three-dimensional, first slot, change in x, second slot, change in y, third slot, change in z. In calculus, we primarily focus on two-dimensional or three-dimensional vectors. In other courses in algebra, you can deal with vectors with many, many more elements than just two or three. Now, the question we want to ask is, what is the length of the vector and what does 1, 3 mean? So how long is that and what does it represent? Again, no fixed location, so pick any generic starting point. In the x direction, we're going to move 1 unit. Boom. And in the y direction, we're going to move 3 units. That's supposed to be 3. So we have our beginning point and our ending point. And the way we geometrically represent that vector is by drawing something that looks like this. Beginning point, ending point, and we're going to call that vector v. And then the question is, what is the length of that vector? And the symbol that we use for length or magnitude of a vector is the following notation. Again, magnitude of vector v is written this way in most textbooks. So how do we determine the magnitude of that vector v? What is our approach going to be? How long is that? If it's 1 unit this way, 3 units this way, how many units is it to go there directly? And I hope it's obvious that we are using the Pythagorean theorem to determine the length of the hypotenuse. So looking at this, we can see that a squared plus b squared equals c squared, or in this case, 1 squared plus 3 squared equals the length of v squared. So we get 1 plus 9 equals the length of v squared. 10 is the length of v squared. So the length of v is just the square root of 10. So indeed, the Pythagorean theorem gets that done for us. We can go ahead and use that to make some sense of it. And that, again, works for a two-dimensional or a three-dimensional vector. We want to tie it to a concept. And the concept we're going to tie it to is the notion of the dot product. So let's discuss that. We don't just multiply vectors. We can add 2 vectors. We can subtract 2 vectors. We don't multiply 2 vectors. We have to define what type of multiplication we're looking at. And one of those types of multiplication is the dot product. So let's take a look at an example of how the dot product works. I'm going to look at 2 vectors in 3 dimensions. Vector u is going to be 1, -2, 5, and vector v will be 3, 0, 1. Again, what does this mean? A vector has magnitude and direction, but it doesn't have a given location in space. Remember, of course, that each of these represents change in x, change in y, change in z. So then what does u dot v represent? How do we get that? Well, to get the dot product, you multiply the change in x's. So that's going to be 1 times 3, plus multiply the change in y's, negative 2 times 0, plus multiply the change in z's, plus 5 times 1. So now that we're here, we can see that u dot v is what? 3 plus 0 plus 5. And we get u dot v is 8. Now, can you think of a way to connect the dot product to the length of the vector? So the vector v that we looked at previously and the work that we did with the Pythagorean theorem showed us that the magnitude or length of v was equal to the square root of 10. So the question I want you to think about is, how can we connect the dot product to the length of the vector? Can we construct a notion similar to the Pythagorean theorem? Remember, a squared plus b squared. Well, the way we connect those is we take the dot product of v with itself. So v is 1 comma 3, v is 1 comma 3. Remember, change in x, change in y. So what is v dot v? 1 times 1 plus 3 times 3, which is 1 plus 9, which is 10. So you will notice then that v dot v is the length of v squared, and this is going to be a big fact for us. V dot v, thanks to the Pythagorean theorem, is going to represent the magnitude of v squared. So to finish this, if you want a formula for the magnitude of v, the magnitude of v is simply going to be the square root of v dot v. So that's how we connect the idea of the dot product with the notion of the magnitude or length of a vector.